Okay, in this video we're going to talk about adding and subtracting rational functions, and again we're going to take our rules from adding and subtracting regular fractions with numbers, and we're going to do the same thing. So let's remember how to add and subtract regular fractions. So let's say that we have 1/3 plus 1/4. Okay, now it wouldn't make sense to add these straight across and get 2/7 because 2/7 would actually be smaller than either one of these, really. So what we need to do is we need to think about what we're doing here. So if we've got 1/3, let's think about what that means. Okay, that's 1/3 of a pi. And then here I've got 1/4 of a pi. Okay, so if I try to put those two pieces together, I don't really know what I have because they're not the same size pieces. So I've got 1/3 and 1/4, but I don't know exactly what that makes. So if we were to compare equal size pieces, then we could put them together. So if I took the 1/3, if I took the thirds and I divided them up, if I took each piece and divided it into 4 pieces, now this doesn't look too pretty because I'm doing it by hand, but I would divide these into equal 12ths, and I would have 1, 2, let me do a different color, that's a little bit hard to see. Okay, let's do blue. Okay, so I have 1, 2, 3, 4 of the 12ths shaded. So 1/3 is equal to 4/12. And remember, that's just the opposite of reducing. 1/3 I can multiply by 4/4. That's the same as multiplying by 1, and I haven't changed anything. So 1/3 is the same as 4/12. And then I do the same thing to the fourths. I divide them into equal pieces, and I'm going to divide them each into thirds. We're going to pretend this is perfect. Okay, and then what do I have here? I've got 1, 2, 3 thirds. So 3/12. 1/4 is the same as 3/12. Okay, and again, you can multiply by 3, multiply by 3. It's the reverse of simplifying. So in the pie on the left, I've got 4 out of 12. In the pie on the right, I've got 3 out of 12. Now these pieces I can put together. I can take the 4 pieces and I can add them to the 3 pieces because now they're equal sizes. So I can add my 4 pieces over here, and I can see that I get a total of 7 out of 12 pieces of my pie filled in. So that's what we're going to do, is we're going to rewrite these fractions to have a common denominator, because if they have a common denominator, those are pieces that we can compare, and then we know that we have 7 out of 12. So when you add or subtract fractions, you need a common denominator, and then you add and subtract the numerator. So for example, a over c plus b over c is equal to a plus b over c. We don't add the denominator. The denominator is giving us the equal size pieces. And if we want to subtract, it's the same exact thing, just with a minus in the middle. Okay, so that's the basic idea here, is that we've got to get a common denominator. Now, it's the best idea to get the least common denominator, but as long as you get a common denominator, you can always simplify in the end and get the final answer the same. So it's best to get the LCD, but as long as you get a common denominator, you'll still be okay. All right, now let's try this with rational functions. All right, so let's say that we've got 3 over x minus 2 plus 1 over x plus 4. Okay, I want to put these together. The denominators are not the same. Okay, denominators are not the same. I need to get a common denominator. These denominators, they're factored. We can see that they have nothing in common. X minus 2 does not cancel with x plus 4. They don't reduce or anything. So our LCD for this would be x minus 2 times x plus 4. Just like our LCD for 3 and 4 was 12, because they didn't have any factors in common. So you multiply them together, and that's your LCD. Okay, so how do I get to my LCD? Well, I've got whatever's missing from my LCD, I need to multiply in here. So here, I'm going to multiply by x plus 4. And to do that, I need to multiply on the top by x plus 4, just like we did with our fractions. And then over here, I need x minus 2. So I'm going to multiply by x minus 2, and again, I've got to do that on the top because I need to multiply by a factor of 1 so that I don't change the original problem. Okay, so we multiply by whatever factor we need to get the common denominator, and we have to do that on top and bottom so we're not changing the original problem. So what do I have now? I've got 3 times x plus 4 over the common denominator, x plus 4x minus 2. And then I've got 1 times x minus 2, or just x minus 2, over x plus 4x minus 2. Okay, we see now that the denominators match, and so we can put them together. So again, we put them together over the common denominator. Okay, it's not as easy to see here that this is our pi size piece, but that's what it is. That's our pi piece. And then we're going to add the numerators. So 3x plus 4 plus x minus 2. Okay, now in the previous ones we factored and simplified and we left it factored, and that's still the same case here. We're going to leave the denominator factored. Now the top has factors, but it's not actually factored because of this plus in the middle. So what I need to do is I need to try to combine like terms up here and then see if it factors again. So I'm going to distribute. I would distribute here, but there's nothing to distribute. And I'm going to see if I have any like terms to group together. So we've got 3x plus 12 plus x minus 2 over the common denominator. And I'm going to come down to the next line. I do have like terms. I've got 4x, and 12 minus 2 would be 10, 4x plus 10, over the common denominator. All right, and then we should check and see now we've got this all simplified, we should check and see if this factors, because if it factors, we may be able to simplify with the denominator. So the only thing I can do with this is a common factor of 2, and that would leave me with 2x plus 5 over x plus 4, x minus 2. Everything's completely factored. We can see that nothing matches up exactly, so that is our final answer. Okay, let's try another one. I think I'm going to need more space, so let's go ahead and erase this. Okay, so the next one is going to be 2 over x squared minus 9 minus 3 over x squared minus 3x minus 18. Okay, now we need a common denominator, but right now we can't see that because in order to find the common denominator, we need to know what the factors are. So the first thing that we need to do is factor this so that we know what we're working with. All right, so the first fraction that factors is the difference of 2 squares. So I'm going to have x plus 3, x minus 3, and I'm going to leave a little space here. And the second one factors as, we need factors of 18 that add up to negative 3. So x minus 6, x plus 3 should work. They multiply to be negative 18, and they add to be negative 3. So those are the right factors. Okay, so now that we see the factors, now we can find the LCD. So remember, just like with numbers, all of your denominators have to go into the LCD, which means that every factor that's in the denominator needs to be represented in the LCD at least one time if there's one factor. Okay, so on the left, we've got x plus 3, x minus 3, so we're going to have that. Okay, so that's our first denominator. Now our second denominator needs to go into this. We've already got the x plus 3, so I don't need that again, but I do need the x minus 6. This factor I don't have yet, so I do need that one. I need x minus 6 in my denominator. So double check, make sure that all of your factors are in the denominator. Okay, so this is our LCD. So now how do I get a common denominator? I need to multiply by whatever's missing. So in this first fraction, I'm missing the x minus 6. And in order to get the x minus 6 in there, I've got to do that on the top and bottom. Then I'm multiplying by 1, and I haven't changed anything. All right, the second one, I'm missing x minus 3. And again, I've got to do that on the top and bottom. Okay, so now double check. Do the denominators match? They do. It's okay that they're in a different order. That's all right. And we can go ahead and combine. All right, so the denominators match. So x plus 3, x minus 3, x minus 6. Okay, so we're going to put this all over our common denominator, and we're going to do 2 times x minus 6 minus x minus 3. Okay, so this numerator minus this numerator. Okay, and they all go over the common denominator. All right, so that was the big step right there. So now again, we need to clean this up. We're going to leave the denominator factored. That's in great shape. The top looks factored, but it's not really because we've got a minus in here. So we need to group all the like terms that we can. So I'm going to distribute, and I'm going to distribute here. When you're doing, when you have a minus between the fractions, don't forget that you have to distribute that over the second group, okay? So on top, we've got 2x minus 12 here, and we distribute. And then we've got minus 3x, and then we've got plus 9. All right, and then the common denominator. Just write that out again. Okay, so now let's see what happens. We've got 2x minus 3x would be negative x. Negative 12 and positive 9 would be negative 3. All over the common denominator. Okay, now, nothing matches exactly. Okay, this doesn't match with x minus 3 because the minus out here. And it doesn't match here, but if you look, it kind of looks similar, right? So if we took a negative out of the top, if we factored that negative out, that's going to change all the signs on the inside. Okay, so take the negative 1 out. Now you've got this. And now we see that we can cancel with the denominator. Okay, so now the x plus 3's can cancel. And remember, when you've got nothing left, you've got a 1 left here, so it's going to be a negative 1 on top over x minus 3, x minus 6. Okay, so a negative 1 on top, or you can also factor that out to the front. That would be the same answer. Okay, so negative 1 on top or negative 1 out front, same thing. Okay, so that's the idea for adding and subtracting. You're going to make sure that you get a common denominator.